Hello and welcome to 13.3. Observations of star-forming regions reveal that a galaxy has spiral arms. So last section we learned that there's a disk, there is a central bulge, and we know that the disk is where all the new stars are forming. The bulge doesn't really have very many new stars, and neither do the clusters. But by observing where the stars are being created, we find out that our galaxy has these spiral arms. Okay, kind of repetition. Dust and gas in the plane of the Milky Way organize into spiral arms, a shape commonly seen in other galaxies. We're going to see how we found that out. Before we do, though, we got to go into some really fancy physics. So we talk about electrons and protons, and if you remember from chemistry or from like 8th grade science, the protons and neutrons are in the center, and there's electrons kind of floating around on the outside. Something that we never talk about is greatly simplified. We can pretend that the protons and electrons are spinning in certain directions. And if they're spinning, we see if they're matching spins like this, they're both spinning in the same direction, they have a lot of energy. But it's possible that sometimes the electrons start spinning the other direction. When they do that, that actually has a little bit of lower energy. Okay? So it's possible that an electron is just chilling in its orbit, rotating around, and as it's rotating, this is also spinning. But then it starts spinning the other way around. When it does that, it kind of releases a little bit of energy. You can almost imagine this as like he's kind of wound up a little bit, and then he kind of relaxes. But when the electron relaxes, he has to give off some light. Okay? So in this spin-flip transition, we get a 21 centimeter radio emission. That's the kind of light that gets emitted when we do this. Now, since we can detect that type of light coming from hydrogen atoms, we can find out where most of that light is coming from. And again, doing a bunch of complicated math, combining this idea of this little photon and the spin and complicated math, we find out that a lot of this light is coming from almost different sections. It's not equally spread out. There's certain areas where there's a lot more of this specific type of light happening. This is a very special type of light that I don't want to say it's easy to detect, but it's my words are failing me. It's special. If we can detect it, we know that there's like hydrogen dust there. So if we detect a lot of it in certain areas, we know there's hydrogen dust in certain areas and not in other areas. So using this new spin-flip transmission of mapping out these specific hydrogen things, using something called Doppler shift, which we talked about, if something is moving towards you, it looks a little bluer than it should be, and if something is moving away from you, it looks a little more red than it should be. Combining all this stuff together, we find out that, yes, indeed, our galaxy has spiral arms. The way we do that is, let's say we're here, and we look this direction, just in one straight line. We detect clusters of hydrogen here, 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 and here, based off of that spin-flip transmission. Okay? Now the spin-flip transmission is giving off that very specific wavelength of light, but we notice in sections 1 and 3, it looks a little more blue than it should be, which means these sections are kind of coming towards us. In section 2, we notice that that is really blue compared to 1 and 3, so section 2 is probably moving faster. Maybe it's coming straight towards us and not like at an angle like 2 and 3 are. I'm sorry, like 1 and 3 are. So you see 1 is coming at an angle, 3 is coming at an angle, and 2 is almost directly heading towards us. And then we get something like 4, all the way over there, who is kind of matching our spin. And if he's kind of matching how fast we're going, that means he's kind of in the same circle that we are, going the same speed, relatively speaking, we're going the same speed, so we don't really pick up a shift there. So we see that there's certain benchmarks, certain areas where certain clouds of gases are moving at certain speeds. And by mapping it out, we get these spiral arms visible. This brings us to this point. Hydrogen gas is not spread uniformly around the disk of the galaxy, but it's concentrated into arched lanes. On the other hand, stars are distributed pretty evenly throughout the galaxy. Where the hydrogen clouds are, there is about 5% more stars there. But the reason why, like, to our eyes, these spiral arms seem to stand out is because these spiral arms are where all the new stars are forming. So because all the new stars are in that cloud of spiral hydrogen, all the new bright and blue stars are there, so we get to see those a little more clearly than the dimmer stars everywhere else. Okay? So this is a little interesting. The gas is not spread out evenly, but stars are pretty much spread out evenly. The only reason why it doesn't look like that is because all of the new stars are with all of the hydrogen. Okay? Hydrogen is unevenly spread. Stars are pretty much evenly spread. But the brighter ones are with the hydrogen gas. Because that's where all the new stuff is happening. That's where all the new stars are forming. Oh, that section is a lot shorter than I thought. We're done with section 13.3 then.